Hello and welcome to today's video. Today's video is for Advanced Geometry Chapter 7 Section 3 Proving Triangles Are Similar. So we have all the theorems and postulates to prove that triangles are similar in this section. Again, when we get to the proofs, I'll do those in class, but I am going to do a couple of the pretty easy examples in the video. Okay, so we start out with angle-angle similarity. So we talked about before the fact that we can't have the AAA batteries angle, angle, angle. It doesn't prove that triangles are congruent. It actually proves that they're similar. You don't need all three angles because of the third angle theorem. So this one says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. This is the easiest one to do. We really can't make these proofs that hard. So I will give you a little hint that any proof on the test probably is not going to be angle-angle similarity because it's far easier than the other one. Okay, so we have an example that says explain why the triangles are similar. So we could quickly say that, well, these angles are the same measure, so they're congruent. There would be one statement. We also have some vertical angles here, so they would be congruent. So we could say that two triangles are similar. Two triangles are similar by angle-angle similarity. Now, the similarity statement would be triangle, and we have to make sure we get it in the right order. RWS is similar, and in class, if I ever write congruence, I have a tendency to do that all the time. Just remind me, similar to triangle VBS. I've written congruence so many times that when we get to similarity, I want to write the congruent symbol. So those triangles are similar. Okay, and we can say angle R is congruent to angle V, equal measures. And if I go in here and call this angle 1 and this angle 2, angle 1 is congruent to angle 2 because of vertical angles. Okay. I'm not writing a proof, so I don't need statements and reasons, but it gives a reason for both sets of angles. Okay, the next one we have is side angle side. So we have side angle side congruence, and now we have side angle side similarity. This one says if an angle of one triangle is congruent to an angle of a second triangle, and the sides including the two angles are proportional, then the triangles are similar. So, for example, if I have two triangles and I say that this is a 30-degree angle, and I say that this is a 30-degree angle, and then I say this is side 2 and this is side 3, and then I say this is side 4 and this is side 6, we could say that the two triangles are similar because we have an angle in each that's congruent. And then the other sides are in proportion. If we take the 4 over the 2, those are the corresponding sides, that equals the 6 over the 3. So this is what would be considered proportional. So this is the one I'm actually going to prove in class. So notice what we're given. We're given angle A is congruent to angle Q, and we're given that AB over QR, so these would be two corresponding sides, is equal to AC over QS. So the corresponding sides are in the same proportion. So I will prove this in class, and it's going to take a while, so make sure when we do it you write small. And the last one we have is side-side-side similarity, and this one says if the corresponding sides of two triangles are proportional, then the triangles are similar. Okay. So it's not that we have all the corresponding sides are congruent. If we have all the corresponding sides are in proportion, then the two triangles are congruent. And we will also do this one in class. But I do want to go through and do a couple of the examples. So using these, explain why the triangles must be similar, write a similarity statement. So for this one, we have this is 3 and this is 6, and then we also have 4 and 8. And because they're right triangles, we can figure out what the third sides are. So we could use side, side, side similarity. We're also given that because they're right triangles, these angles are 90 degrees. So we could say that angle R is congruent to angle Y. They're both right angles, so this would be the right angle theorem. And then if we take a look at the sides, we can do, now in this case, because we're using the fact that the corresponding sides are in the same proportion, we shouldn't do 6/3, because that would show that the ratio within the triangles would be the same. What we want to show is the ratio between the corresponding sides is the same. So if I do 8/6 or 6/8, that is equal to 3/4. And sure enough, that is true. Okay. So our similarity statement would be that triangle PRQ is similar to triangle ZYX by side angle side similarity theorem. Now, if we want to find parts of it, it wants me to find DE, and it tells me the triangles are similar. That's going to be important. We can't just look at them and say, oh, they look similar. They have to be given that they're similar, or we have to be able to prove that they're similar. For this one, what we can do is we can take two of the sides that are in the same proportion. Okay. Now, for this one, the issue I have with this one is if you take a look, this is 12 and this is 24 and this is 16 and this is 18. So there's no way that if we did 12/24 that equals 16/18. So it can't be true that they're similar by just the reflection of each other. If we go across and we do the 12/18, that is equal to the 16/24. Okay. So for this one, 12/18 equals 16/24, and if we reduce that, this reduces into, let's see, 2/3. Now, once we get that ratio, we can use that ratio or any of the original ratios. We could use the 12/18, the 16/24, or the 2/3 to find the other side. So we can call this side x, and then we can say, well, the ratio of the sides is 2/3, so the ratio of the last sides must also be the same. And since the 10 is on the smaller one, x is on the bigger one, we get 2x equals 30 and x equals 15. And it wants me to find DE, and DE is 15, so the answer is B. Okay. So notice what I did. I first figured out in which way the triangles were similar using the given sides. And then what I did is I reduced the ratio, and then I used that to find the third side. And the last one, indirect measure. I know you guys did this a couple years ago. You guys did like reflection, and you used also shadows, and we're going to do those also in this chapter. So it's kind of cool. We're going to redo those. But indirect measurement is using similar triangles and measurements to find distances that are difficult to measure directly. Now, once we learn trig, we won't be using mirrors and shadows anymore, but we do want to learn about similarities, so we'll use them here. So Raymond places a mirror on the ground 40.5 feet from the base of a geyser. He walks backwards until he can see the top of the geyser in the middle of the mirror. At that point, Raymond's eyes are 6 feet above the ground, and he is 7 feet from the image in the mirror. Use similar triangles to find the height of the geyser. So first we have to figure out how are these similar, and we've got two right angles, T and S, so they're going to be congruent. Also, angle of reflection, as we know, is going to be congruent, so these two angles down here at the bottom are also going to be congruent. So what we can see from this is that angle-angle similarity tells me that triangle HTV is similar to triangle, is that a J? JSV. So what we can do is we can set up a proportion between the two. Now again, I'm going to use like this similarity and set it up the way they intend you to set it up. If you want to set it up in a different way that works, that's fine. But for this, I can take two sides that I know that are corresponding. So I know that this is 7 feet and I know this is 40 feet, and I can make a ratio of them. So 7 out of 40.5. And that has to be equal to the ratio of the two sides, one of which I know, one I don't know. So that would be equal to 6 over x. Okay. And then I can cross multiply, so 7x equals 243. And then I can divide both sides by 7, divide by 7, and x equals 34 point, now I'm going to round, so I'll round it to the nearest tenth of a foot. So 34.7 feet tall, about. And that's the end of today's section. Thank you for watching. Have a great day. Take care.